Day. Here I am all stressed out about how do you say it though? Like, how would you say it? No, just no. But Wei Hua. Yeah. Okay, Jason. I like Jason. That works out for me real well. But I'll try Wei Hua. That's it. I tried it one time. All right. Jason. All right, Jason. I might just give group work from now on. I need to stop talking today. Would you like to plug in everything? You want to help me out with this?
Sure.
Okay, so. Okay. Go ahead. X cubed. So what's x cubed going to be? Cubed. So what's 3 halves cubed?
27 over
27? 8. 27 over 8. Tan cubed. Theta. Good. Over.
will be equal to 3 over 2 secant theta.
3 over 2 secant theta, right?
Plus
Well, the whole root, right, is 3 over 2 secant theta, and then cubed again. Right? So what happens when you cube this?
there will be 27 over 8.
That's nice, isn't it? Secant cubed theta, all right. Times, good. Don't forget the dx, right?
There will be
3
3 over 2
over 2
secant theta.
secant theta squared d theta. Wow. All right. Everyone see where all that came from? All right, I think we can clean this up pretty easy. That part's easy. All right, how about that 3 halves? Let's take it out of the integral. So we will have 3/16, I believe. I'll just write that out front. Yeah, I'm going to kill off some other stuff too. So that 3 halves is going to go away. That's going to go outside. And then I've got 2 of the secants go away. I'll be left with 1, so that's basically gone. And I still have the tangent cubed on top. So tan cubed theta over secant theta, just a single factor, d theta. Right, Jason?
To get 3/16, did you just divide by?
I took 3 halves out, so times 3 halves, right? And just straight across. We all good? Does it feel like we're only halfway through this class? It feels like we've been here longer than that. Is it just me? All right, well, we're at a point where I need y'all to figure out what the heck you're going to do here. Would you like to continue, Jason? I would like for you to.
Okay. If I'm right, we do the triangle? Not yet.
Not yet.
Okay.
So the question was, Jason was asking, is it now the time for the triangle? The triangle comes at the end when you actually have found the antiderivative, and you're trying to plug in to figure out what the answer is, back to x. So now you just have to integrate that. Do you peel a tangent out? You might be able to pull a tangent out.
U substitution.
You could do a u sub. What would be your u be? Secant theta? But wait a minute, what's the derivative of secant theta? Secant tangent, I don't see a secant on top. You could go sine and cosine. There are 2 or 3 different ways you could do this problem. But you see that we finally, after all this work, have finally got it down to a trig integral. Yeah? So, Jason, did you say you wanted to pull a tangent? What? I forgot what you said you wanted to do. Or if you didn't say, okay. So I'll let you decide.
Maybe peel out 1 tangent.
If we peel out a tangent, we'll be left with this tangent squared, right? What are you going to do with that, though? So look, if I have, I'm just writing this down just to think through it. If I peel out a tangent, I've got tangent over secant like this, and then this is a single tangent here. The problem with this is that tangent theta d theta is not the derivative of anything,
But it's 10.
True.
right?
Secant squared theta is.
What identity? Change that to secants? Okay, let me go with that. That would be secant squared theta minus 1 over secant theta, then tangent theta d theta, okay.
Now you use secant.
Yeah, I'm going to come back to the 3 over 16, don't worry. I'm just trying to see if we're going anywhere. Does this get us anywhere?
Yeah,
What do you do?
you use secant.
I don't see u being secant. If u is secant, that'll be u. What's the derivative of it? Derivative of secant is secant tangent, and you don't have secant tangent, you just have tangent. And you can't pull this one out here because there's two terms here. Got it? It's important that we hit dead ends, okay? Because you're going to hit dead ends. I'm just not convinced whether or not we've hit the dead end yet. I'm pretty sure you can make this one work.
Can you turn the tangent into could you turn the original one and the sine and cosine?
Okay, so when you get to a point where you're starting to, like, the wheels are coming off and you start to feel a little bit unsure about whether or not you're going to get there, I always recommend you go back to the original problem and just turn everything in terms of sine and cosine and just see what happens. Maybe you'll get lucky. Now, like I said, I believe this one will still work because what I would do at this point is split this into two fractions. You'd have secant squared over secant, which would be secant theta. Then you have 1 over secant, which is 1 over secant is cosine theta, right? Then you have tangent theta over here. You with me? Distribute through. Tan times secant is secant times tangent. Hey, what's the antiderivative of secant times tangent? Just secant. This times this, tangent sine over cosine. So when I multiply times cosine, it's just sine. Antiderivative of sine is negative cosine. This will work, okay? This will work. But I think that yeah, because I want to just show that there's multiple paths, and I think the cleanest path from here is sine and cosine. So I'm going to go 3 over 16 integral. All right, tangent cubed is the same as sine cubed over cosine cubed over secant, which is 1 over cosine, d theta. Now I'm going to flip, and when I flip, all that's going to happen is I'm going to lose 1 cosine, right? So 3/16 integral sine cubed over cosine squared d theta. That good? And now peel a sine off. I'm coming to peel a sine off now. When I peel off that sine, I get sine squared theta over cosine squared theta times sine theta d theta. Now, you might be tempted to turn sine squared theta over cosine squared theta into tangent squared theta. That you might be tempted. Well, why did we peel off a sine? We want that to be our du, don't we? That means we want u to be cosine, don't we? Which means you should probably try and get everything else out there that you see in terms of cosine. So, do you understand what I'm saying? Like, if you peeled off a sine, then that's the derivative of your u. So that means u needs to be cosine. We'll be off by sine, but 1 minus cosine squared theta. That's sine squared theta, right? Over cosine squared theta. times sine theta d theta. And now we're ready for u sub. Okay. U is cosine theta. Du is negative sine theta d theta, right? So I'll go ahead and take care of that negative now. Everyone see what I'm doing here? The negative I already counted for it over here. Now I get to rewrite the integral. 3/16 integral 1 minus cosine squared is the same as 1 minus u squared over u squared, yes. And then negative du, right? That's negative du. So I'm going to put the negative way out here on the 3/16. I'm so close. One more step, and then I can do what? There's two ways you can approach this. You can say, I'm going to bring the u up as a u to the negative 2 and distribute through, or you can just split this into two fractions. I'm going to go two fractions, like 1 over this and then u squared over this. We're so close. Integral. We do the 1 over u squared first, right? That's u to the negative 2. Minus 1 du. Does it feel like we're doing calculus now?
Yeah.
Does this feel like you've used a page and a half of paper yet? Okay. This is why the homework solutions for this section, if you didn't notice, required 4 hours from me. It took me 4 hours to do the homework for this. Which means if you're actually doing it on your own, it should probably take you at least double that if you're actually, because you've got to hit the barriers first, figure out other ways around it. If you just watch me do it, of course, that's a lot different. So this is a big homework section. The next one is the same way. It's very long. Antiderivative. So don't mess it up now. I mean, we've come this far. Don't mess up the antiderivative on this. I'll leave the negative 3/16 out. And antiderivative of u to the negative 2. Negative u to the negative 1. Antiderivative of 1. U. So minus u plus c. We finally have gotten to a place where we're at plus c.
And then we got to do cosine.
Yeah, let's go back to cosine, then we're going to go back to x. All right. So u is cosine theta, right? So this becomes negative 3/16 minus, all right, this is cosine theta to the negative 1, which means 1 over cosine. Secant. So this is secant theta. And then minus u, which was cosine theta plus c. Distribute? I will now, I guess. 3/16, bless you. Secant theta plus 3/16 cosine theta plus c. Deep breath. Now, Jason, reference triangle. I'm only the messenger. Okay? This is the message. I've forgotten what our trig substitution was. X is 3/2 tan theta?
Professor, by the way,
Yes.
on number 4 on the solutions video, you said u was sine. It's actually cosine.
I said it, but wrote it down right?
You wrote it down right, but said it wrong. And
Oh,
then wrote
okay.
it down wrong.
So there's an error?
There is an error.
If you find it, email me about it. I'll fix it, and I'll give you a point or two. Yeah.
No.
All right, so now I'm going to go for my triangle now, right? I'm going for my triangle. X is, correct me if I'm wrong, 3/2 tan theta. That was a long time ago. Is that right? Yes. Okay. From that, I need to create the triangle, but I need to get tan theta by itself. So clear out the 3/2. Multiply both sides by 2/3. and you'll get 2x over 3. That's what I would get if I multiplied both sides by 2/3. Tangent is opposite over hypotenuse. No, it's not. It's opposite over adjacent. We're 2x, right, and 3? Yeah. Okay. Which means the hypotenuse is, now, be extremely careful on the hypotenuse on this one. I've told you all the way up to this point that the missing side will always be that root thing, right? But because we'd factored that 4 out, remember that 4 we pulled out in the very beginning? Okay, you are thinking that it's going to be x squared plus 9/4. But it's not, this is not x squared plus 9/4. This is actually 4x squared plus 9. So just be aware of that. If you wind up pulling a number out, when you get to this step with that root, it's going to be the original root. It's not going to be after you've factored something out. You can see it though, right? Like a squared plus b squared, or a squared plus b squared is c squared. So all right. Well, I don't even know what we're doing anymore. Okay, secant theta right here and cosine theta. That's what we're trying to do. We're there, right? This is about to be the final answer. 3/16 secant theta, which is the reciprocal of cosine, which is, all right, so we should have the hypotenuse over the adjacent plus 3/16 and then cosine theta, which is
It's flipped. It's the inverse.
adjacent over hypotenuse. So this time 3 over root 4x squared plus 9 plus c. Little cleaning up to do and I'm done? I'll clean it up. Final answer. My final result is 1/16, because these 3's cancel. Square root is what? I think the negatives went away back here when we distributed the negative through. Right here, negative right here. And then plus what? 9/16, right? So can I write it this way? 9 over 16 roots of, well, better yet, I'm going to write it this way. You just tell me if you agree. 9/16 4x squared plus 9 to the negative 1/2. Isn't that the same? Plus c? Yeah, but y, right? Okay, that's the answer. Yes? Whew, that took like what, 20, 30 minutes? Now the reason I wrote it like that is because I'm about to take derivative. I'm going to check my answer. It's not that bad. Trust me. What is it that we're trying to get? When I take derivative of that, we should get x cubed over square root 4x squared plus 9. Why does everyone, when I start taking derivatives, everyone's like, okay, I'll go take a water break. Nobody likes taking derivatives? Huh?
None of
No,
that.
Why?
3 over 2. 3 over 2.
3 over 2, thank you. Oh, no, I have the root.
No, it was like that.
Oh, yes, I know what the original one was, but you agree if I can get it to that, we're there, right?
No, you with the 3 over 2. Oh, yeah.
With the radical, it's the same. All right, so look, here we go. Derivative of this, 1/16 comes down. Derivative square root of something is 1 over 2 times the roots of that something times derivative, what's in there, 8x. Good enough? Okay. Plus 9/16 constant, comes for the ride. Negative 1/2 pops out. All of that to what power? Subtract 1 from negative 1/2, negative 3/2. Okay, times derivative what's inside, 8x again. Yeah? Yeah, that's it. That's the derivative. Obviously, that's that, right? No. Okay, so look, 8, 16, that's a 2, isn't it? Yeah? So this is actually 1 over 4, because we had 2 times 2, root 4x squared plus 9. Over here, plus, no, it's actually minus. Anything go away? We have 8, 16, that's going to be a 2 on the bottom. So 2 and 2 is 4, so 9/4. And this x. Oh, I forgot the x up here. Y'all let me forget that x. So we have 9/4. Put 9x over 4x squared plus 9 to the 3/2. Y'all agree? All right, I'm going to get a common denominator because I'm very close to already having one. Remember, this right here is the same as that, right? So I need 3 of these roots. Over here I have how many of them? 1. I need 2 more. So how about if I put 2 more of those roots here? Well, what is the root squared? Itself, right? So I have to put it up top again? Y'all realize what I'm really doing here? This is just a 1. So I've got what? A root, there's 2 of them, and then there's a third one. So putting those together, I have 3 roots total. But 2 of the roots, right, is just this itself. Now distribute. X goes to here, x goes to here, right? What's your new numerator going to be? 4x cubed plus 9x, but minus 9x because I have the same denominator, over my common denominator, 9x's cancel, 4's cancel, and I'm there. That's reassuring that it works. I know that's sloppy derivative up there, but I'm just trying to convince you that it worked, all right? If you followed it, great. If you didn't, it's okay. You can play it in slow-mo. How are y'all feeling about this? It's a lot going on here, huh?
No, surely you wouldn't ask something like that on the test, would you?
Surely I wouldn't ask you something like that on the test.